This $90 steel tank can store your solar energy for 30 years with zero degradation. No lithium, no cobalt, no toxic chemistry, no firmware updates. Full capacity, decade after decade after decade. A durability that no battery on the consumer market can match. Yet despite the physics behind it being documented, published, and proven for over 360 years, every solar installer in America will tell you the same thing. Storage means batteries. Batteries mean $15,000. And $15,000 means you are now a repeat customer for life. That is not an energy plan. That is a subscription. The technology I am about to walk you through is called compressed air energy storage. By the end of this, you will understand the science behind it, why it was buried under a mountain of lithium marketing, and exactly how to build a working system in your own garage for less than the cost of a single monthly electric bill. Let us start with what you're actually paying for right now and why the product you have been sold begins failing the moment it arrives at your house. The dominant home battery in the United States is the Tesla Powerwall 3. It stores 13.5 kilowatt hours of usable energy. The installed price, depending on region and installer markup, falls between $14,800 and $16,200. Tesla backs it with a 10-year warranty. That warranty guarantees the unit will retain at least 70% of its original capacity by year 10. Read that again. The manufacturer is telling you, in writing, on their own warranty document, that losing 30% of what you paid for is the acceptable outcome. That is not a defect. That is the design. 70% is the floor Tesla is comfortable printing on paper. Independent data suggests reality can be worse. The battery test center operated by ITP Renewables in Canberra, Australia, has tracked real-world performance across thousands of residential battery units, including Powerwall 2 systems, and found measurable capacity loss that accelerates with cycle count and temperature exposure. At 1 cycle per day in a moderate climate, significant degradation becomes apparent well before the warranty period ends. There is a clause in the Powerwall 3 warranty that most buyers never hear about until it is too late. The unit must maintain a continuous internet connection to your home network. Tesla's own installation manual states that internet connectivity is required to receive the full 10-year warranty. If the unit loses that connection for an extended period, the coverage can be reduced. You are spending $15,000 on a device that requires ongoing digital permission from a corporate server to honor its own guarantee. You do not own the warranty. You lease it, contingent on a Wi-Fi signal. Now run the replacement math across the actual lifespan of your solar array. Your rooftop panels carry warranties of 25 to 30 years. Over that period, you're looking at 2 to 3 battery replacements. That is $30,000 to $48,000 in storage costs alone, just to use the electricity your own panels produce. Each discarded battery pack is classified as hazardous waste under federal guidelines. Lithium-ion cells cannot go in residential trash. They require specialized collection, transport, and processing. Currently, fewer than 15% of lithium-ion batteries in the United States are recycled. The rest sit in hazardous waste storage or end up in landfill, leaching heavy metals into groundwater on a timeline measured in centuries. The supply chain that produced that battery is worth understanding because you are paying for every mile of it. The lithium itself is extracted primarily from 2 sources. The first is the Atacama Desert in Chile, where lithium-rich brine is pumped from beneath salt flats and evaporated in massive open-air ponds. The process consumes approximately 500,000 gallons of water per ton of lithium carbonate produced. In one of the driest regions on the planet, local communities and indigenous populations have reported devastating drops in their water table. The second source is hard rock spodumene mining in Western Australia, a conventional open pit operation with all the environmental disruption that implies. The cobalt in those battery cells comes overwhelmingly from the Democratic Republic of Congo, which supplies roughly 70% of the world's cobalt. Amnesty International published a detailed investigation in 2016 documenting children as young as 7 working in artisanal cobalt mines under hazardous conditions. That cobalt is shipped to refineries in China and South Korea, assembled into cells, packaged into modules, shipped across the Pacific, delivered to your house, bolted to your garage wall, and in 10 years the whole thing gets ripped out and the cycle restarts from the mine. That is the system we are told is the only path to energy independence. Now let me show you what a steel tank and atmospheric air can do instead. The core scientific principle behind compressed air energy storage is one of the oldest verified laws in physics. It is called Boyle's Law, published in 1662 by the Anglo-Irish natural philosopher Robert Boyle. The law states that when the temperature of a confined gas is held constant, the pressure and volume of that gas are inversely proportional. Compress air into half its original volume, and the pressure doubles. Compress it to 1/10, and the pressure increases tenfold. That pressure is stored mechanical energy. It does not decay. It does not degrade. It does not depend on chemical reactions, cell balancing software, or a server in Palo Alto. The air holds its energy until you release it. Period. There is no calendar life. There's no cycle limit. There's no degradation curve. The physics are 363 years old, and they have not changed once. In a compressed air energy storage system, the process works like this. During the day, your solar panels generate electricity. That electricity powers a standard electric air compressor. The compressor takes atmospheric air and pushes it into a pressure-rated steel vessel. In this configuration, that vessel is a repurposed ASME certified propane tank, the kind used for residential propane storage across rural America. When the sun goes down and you need electricity, you open a valve. The pressurized air flows through a small air motor. The air motor spins. That rotational energy drives a generator. The generator produces electricity. That is the entire system. 4 components: a compressor, a tank, an air motor, and a generator. No lithium chemistry, no thermal runaway risk, no fire suppression requirement, no cell management software. No internet connection, no corporate server granting permission for your own stored energy to function. There is a second physical principle that makes this system even more practical at the household level, and it is the reason compressed air storage can replace more than just your battery. When air is compressed, the molecules are forced closer together and the temperature rises. That is a direct consequence of the ideal gas law. In most industrial compressor setups, that heat is dumped into the surrounding air through a cooling fan and wasted entirely. But in a residential system designed with intention, that heat is captured. A simple heat exchanger, which is nothing more than a coil of copper tubing submerged in a water tank, routes the compression heat directly into your domestic hot water supply. When you later expand the air to generate electricity, the air cools as it depressurizes. That cold output can be ducted into your living space for cooling or routed through your refrigerator intake to reduce its electrical load. This combined approach is called polygeneration. A single compression and expansion cycle produces 3 outputs simultaneously: electricity, heat, and cooling. No chemical battery on the market does that, not at any price. The laboratory evidence for this is not theoretical. Researchers at multiple institutions have built and tested working micro-CAES prototypes. A team at the AGH University of Science and Technology in Krakow, Poland, constructed a functioning microcompressed air energy storage system using a reciprocating piston expander. They published their results and found that with pulse width modulation control of the expansion cycle, they could achieve a round-trip electrical efficiency, reaching into the range of 60 to 80%, depending on operating pressure and configuration. The system generated over 1 kilowatt of continuous electrical output. That is enough to simultaneously power household lighting, a refrigerator, a phone charger, and a Wi-Fi router. A separate body of research from the University of Florence in Italy modeled a small CAES system operating at 200 bar with a storage volume of just 0.55 cubic meters, roughly the footprint of a standard hot water heater. That system captured the overwhelming majority of excess solar energy from a residential rooftop array while also producing enough waste heat to generate 270 liters of hot water per day. When the thermal contribution is factored in, the overall exergetic efficiency of the system approaches 70%. That is comparable to lithium ion. Except the storage vessel does not degrade. It does not need replacing. And it was not mined from a desert or assembled by children. Every researcher who has tested these systems arrives at the same conclusion about the storage vessel itself. A steel pressure tank does not have a cycle limit. It does not have a calendar life. It does not suffer from chemical degradation, dendrite formation, or electrolyte breakdown. It holds air. Air does not expire. The vessel can be charged and discharged tens of thousands of times across decades without any measurable change in its storage capacity. That is not a marketing claim. That is material science. Steel under rated pressure does not fatigue in the way lithium chemistry does. It simply holds. But the laboratory results are only one layer of the evidence. The proof that compressed air can deliver reliable, sustained industrial-grade power has been demonstrated at scales most people never hear about, and it stretches back further than the battery industry would prefer you to know. In 1857, engineers began construction on the Frejus rail tunnel beneath the Alps, connecting France and Italy through nearly 13 kilometers of solid alpine granite. The project was one of the most ambitious civil engineering undertakings of the 19th century. The drilling teams used pneumatic rock drills powered entirely by compressed air. Those tools replaced manual labor and increased drilling speed from roughly 60 centimeters per day to 2 meters per day. The tunnel took 14 years to complete and proved, at a scale no one could argue with, that compressed air could deliver reliable, sustained mechanical power under the most extreme conditions on Earth. Within 2 decades, an Austrian engineer named Victor Popp took that same principle and applied it to an entire city. In 1879, Popp founded the Compagnie Parisienne de l'Air Comprimé in Paris. Starting with a network of pneumatic clocks synchronized by compressed air pulses through underground pipes, Popp's company rapidly expanded into powering industrial equipment across the city: elevators, lathes, sewing machines, commercial beer taps. The system operated through a distribution network of pressurized pipes running beneath the streets of Paris. By the early 20th century, the company was serving thousands of commercial and industrial clients. The network ran continuously for 115 years, from 1879 until 1994. Paris did not shut it down because the technology failed. It closed because local industry declined, and maintaining aging underground pipes was no longer economically justified. The compressed air itself never stopped working. 115 years of continuous municipal service. No battery system anywhere in the world has come within a century of that record. Then there's the utility scale proof. In 1978, engineers commissioned the Huntorf compressed air energy storage plant in Lower Saxony, Germany. The system stores compressed air in 2 underground salt caverns totaling 310,000 cubic meters at pressures between 43 and 70 bar. At commissioning, it delivered 290 megawatts of electrical output. That plant is still running today. 47 years of continuous operation. In 2007, it was upgraded to 321 megawatts. The original mechanical systems have never required a storage medium replacement. There is no lithium installation anywhere on the planet that can make that claim. In 1991, a second large-scale CAES plant went online in McIntosh, Alabama. Built by the Alabama Electric Cooperative, the McIntosh facility stores air in a salt cavern 1,500 feet underground with a volume of 19.8 million cubic feet. It delivers 110 megawatts for up to 26 hours per discharge cycle. That is 2,260 megawatt hours of storage capacity. The cost per kilowatt hour of installed capacity at McIntosh works out to roughly $20 to $30. Compare that to the Tesla Powerwall 3 at approximately $1,100 to $1,200 per kilowatt hour installed. That is a cost difference of over 40 to 1. And the McIntosh salt cavern has a projected operational life exceeding 100 years. You do not need a salt cavern or a utility scale budget to prove the concept. The Amish have been demonstrating it for decades. Communities across Lancaster County in Pennsylvania, Holmes County in Ohio, and LaGrange County in Indiana run entire workshops and significant portions of their domestic infrastructure on compressed air. They use engine-driven compressors to fill large ASME-rated steel tanks, then distribute the pressurized air through steel pipe networks. That air powers table saws, drill presses, sanders, lathes, grain mills, and pneumatic submersible water pumps, pulling from wells over 150 feet deep. In some communities, compressed air even powers washing machines and small refrigeration units. These are not experiments, they are not prototypes, they are functioning infrastructure that has been in daily use across multiple states for generations. The Amish discovered what the battery industry would prefer you never seriously consider. You do not need to convert energy into chemistry and back again. You can store it as pressure, and pressure does not degrade, does not require replacement, and does not end up classified as hazardous waste. So the obvious question becomes this. If the physics have been proven since 1662, demonstrated at tunnel scale since 1857, deployed at city scale since 1879, operational at utility scale since 1978, and used at community scale by the Amish for decades, why can you not walk into a hardware store and buy a residential compressed air energy storage unit? The answer is not performance. The answer is paperwork. Every financial incentive in the American residential energy market was architectured around lithium-ion chemistry. The Inflation Reduction Act of 2022 created a 30% federal tax credit for standalone residential energy storage systems of 3 kilowatt hours or larger. The IRS defines eligible storage technology under Section 25D as equipment which receives, stores, and delivers energy for conversion to electricity. A compressed air energy storage system meets that definition exactly. On paper, it qualifies. In practice, the credit is unreachable. No manufacturer has obtained a UL listing for a residential micro-CAES product. No installer certification pathway exists. No permitting framework has been established in any major American municipality for a compressed air storage installation. Without a certified product and a licensed installer, no tax professional will file the credit. No home appraiser will recognize the system as a property improvement. No insurance underwriter will add a coverage rider. A homeowner who installs a Powerwall gets a 30% federal credit, a turnkey installation, a product recognized by Fannie Mae appraisal guidelines, and an insurance rider that covers the unit from day one. A homeowner who builds a functionally superior compressed air system for $500 gets none of that. No credit, no appraisal value, no rebate, no coverage. The system was never designed to ban compressed air storage. It was designed exclusively around batteries. And in a regulatory environment where tax credits, UL listings, and installer certifications determine what gets built, anything outside that architecture is invisible. Invisible, in a market structured this way, is functionally identical to prohibited. Here is what you need to build one. The storage vessel is a standard ASME certified propane tank. ASME certification matters because these tanks are built from heavier gauge steel with stronger welds than DOT portable cylinders. The critical advantage for energy storage is that ASME tanks have no federal recertification requirement. A DOT cylinder must be requalified every 12 years. An ASME tank is certified once at the factory and remains certified for the life of the vessel, which routinely exceeds 30 years with zero structural maintenance. A new 120-gallon ASME vertical tank from manufacturers like Manchester Tank runs between $400 and $600 retail. A used or decommissioned tank from a propane company retiring older inventory typically sells for $50 to $120. These vessels are rated for working pressures of 250 psi and were engineered to contain liquefied propane under direct sun exposure. Holding compressed air at 150 psi is well within their design margin. For the compressor, select an oil-free electric unit rated for at least 150 psi continuous duty. California Air Tools and Makita both produce reliable models in the $200 to $400 range. Oil-free operation is not a preference, it is a requirement. The air entering long-term storage must be clean and dry. Oil mist from a lubricated compressor deposits a film on interior tank walls over time, creating a potential ignition hazard at high pressure and accelerating corrosion. Add an inline moisture separator and desiccant filter at the compressor outlet. These run $20 to $40 and eliminate the water vapor that would otherwise promote internal rust over decades of service. The air motor converts stored pressure back into rotational energy. Manufacturers like Gast and Parker Hannifin produce vane-type pneumatic motors designed for continuous industrial use, priced between $150 and $300. Connect the air motor shaft to a permanent magnet DC generator or a compact automotive alternator. The output feeds into a small 12-volt deep cycle buffer battery costing $60 to $80. This buffer battery is not your storage. The tank is your storage. The buffer battery exists only to smooth voltage fluctuations during the pressure drop at the end of a discharge cycle and to provide a stable reference for your DC to AC inverter. Total component cost for a functional residential microcompressed air energy storage system runs between $500 and $1,200, depending on whether you source new or used components. That is 3 to 8% of a single Powerwall installation. And the steel tank at the center of that system will still be holding air at full rated pressure with zero capacity loss when the third replacement lithium battery is on its way to a hazardous waste processing facility. One critical safety rule: never use PVC pipe for compressed air distribution. PVC becomes brittle under sustained pressure cycling and temperature variation. When it fails, it does not crack. It shatters violently. Sending fragments at velocities capable of causing fatal injury, use black iron pipe, copper tubing, or aluminum pipe rated specifically for compressed air service, and install a pressure relief valve on the storage tank set to open at approximately 10% below the vessel's maximum rated working pressure. These valves cost $8 to $15. They are the single most important safety component in the entire system. They prevent catastrophic overpressurization in the event of a compressor regulator failure. If you are designing a system intended to operate above 200 psi, consult a licensed mechanical engineer for pipe sizing, relief valve specification, and vessel inspection. Now, the honest limitations, because any system worth building is worth understanding completely. Round-trip electrical efficiency for a basic residential compressed air setup runs between 30 and 65%, depending on compressor quality, expansion method, and whether thermal recovery is implemented. Lithium-ion batteries achieve approximately 85 to 90% round-trip electrical efficiency. On a per-cycle basis, lithium is more efficient. That is a fact, and there is no reason to hide from it. But efficiency per cycle is not the same as lifetime value. A system that operates at 50% efficiency for 30 years produces vastly more total energy over its lifetime than a system that operates at 90% efficiency for 10 years and then goes to landfill. Because the first system is still running when the second system is being replaced for the third time. Lifetime total output, not peak cycle efficiency, is the metric that determines real-world economic value. The second limitation is mechanical complexity. A compressed air system uses a motor and generator to convert stored pressure back into electricity. That is more moving parts than a lithium battery, which has none. But those moving parts are rebuildable with standard hand tools. A dead lithium cell is not. You cannot open it, you cannot repair it, you cannot refurbish it in your garage. It is a sealed chemical package that either works or becomes waste. An air motor that wears after 15 years of daily service gets new vanes for $20 and goes back into operation the same afternoon. The third limitation is noise. Air compressors generate sound during the charging cycle. If your installation is near a property line or a neighbor's bedroom window, plan for sound insulation around the compressor enclosure. Acoustic foam panels and a plywood baffle box reduce operational noise to levels comparable to a household refrigerator. Alternatively, schedule compression during daytime hours when ambient noise is higher and the solar panels are actively producing. Compressed air energy storage is a 363-year-old answer to a 21st century problem. It stores energy as pressure inside a steel vessel that costs less than a single monthly electric bill and lasts longer than most home mortgages. The Huntorf plant in Germany has been operating since 1978 without a single storage medium replacement. 47 years. Victor Pop's compressed air network served the city of Paris for 115 years. The Amish have run workshops on it across 3 states for decades. The physics were published by Robert Boyle in 1662 and have not required a single revision since. And a used ASME propane tank from a scrapyard holds pressure today exactly the way it did the day it left the factory. No capacity loss, no degradation curve, no warranty that expires, no server that needs to stay online, no mine in Chile that needs to keep pumping, no child in Congo that needs to keep digging, just steel, air, and the oldest gas law in the textbook. A lot of what falls outside the mainstream energy conversation does not sit there because it stopped working. It sits there because the financial infrastructure was built around the product that costs more, degrades faster, ships from farther away, and needs replacing more often. If you had roof space for solar and the budget for one storage system, which would you choose? $500 in steel and air that you can repair with a wrench and a $20 parts kit, or $15,000 in lithium chemistry that needs a Wi-Fi signal to honor its own warranty? That is not a rhetorical question. That is a genuine engineering decision. And for the first time, you now have enough information to make it yourself.